Hello everyone. In this video, we're going to explore the end behavior and concavity of the exponential functions. So exponential function is given by the formula y equal to a times b power of s, where a is the initial value or the y-intercept, b is the common ratio. Now, a must be different from 0. B must be different from 1. Alright, so we have two different cases. If B greater than 1, this is the exponential growth. If B greater than 0, less than 1, this is the exponential decay. Now we have four different cases. The first case, a greater than 0, b greater than 1. Alright, so this is exponential growth. So the function rise from left. So it's going to be something like this. Now, the second case, a greater than 0, b greater than 0, less than 1. So this is exponential decay. So the function falls from left. Now the third case, a less than 0, b greater than 1. The function looks like this. And the last case, a less than 0, b greater than 0, less than 1. So the function looks like this. So in four cases right here, the exponential function receives the x-axis as the asymptote. Alright, so this is the x-axis. The function of the x-axis is y equal to 0. Keep that in mind. The function of the y-axis, which is x equal to 0. We're going to use decimals to demonstrate the graph of four different cases of the exponential functions. The first case, a greater than 0, b greater than 1. So I'm going to let a equal to 1 and b equal to 2. Alright, so I have the first exponential function, y equal to 1 parenthesis 2 power of s. Alright, so it's going to be like this. Now the second case, I'm going to let a equal to 1, but b equal to 1/2. So let's see how it looks like. Y equal to 1 times 1/2 power of s. Right, it's going to be like this. So look, it looks exactly the same thing as this guys right here. Now, case number 3. A less than 0, b greater than 1. So I'm going to let a equal to -1, b equal to 2. So the third case, y equal to -1 times 2 power of s. Alright, it's going to be right here. So it looks like this one. And the last one, a less than 0. So I let a equal to -1. And b from 0 to 1, so I let b 1/2. Alright, so I'm going to have the last one. So y equal to -1 times 1/2 power of ask. So it could be like this. Alright. Now we're gonna explore the end behavior and concavity as well as increasing or decreasing. Alright. Now, in order to explore the end behavior of the exponential function, the first thing we need to do is to put the positive infinitive on the right of the x-axis, negative infinitive on the left of the x-axis, positive right here, and this is negative right here. Alright, so limit of the function f of s. So this is the function f of s. When s approaches negative infinitive, so you see that when s approaches negative infinitive, which means s going further to the left, the function is the red line right here, getting closest to the x-axis, and as we know that the x-axis, which means y equal to 0. So the limit of the function f of s when s approaches negative infinitive is going to be equal to 0. Now b, limit of f of s when s approaches positive infinitive. So which means s going further to the right, right? And the function going up. So which is the function approaches positive infinitive right here. Alright, so it could be positive infinitive. Now next one, we need to explore to see if the function is increasing or decreasing at an increasing rate or decreasing rate. Alright, so before we do that, let's take a look at the trick. We call this is Christmas tree trick. Alright, now if you see the lines going up from left like this is increasing, which is the slope is positive. The guys going down from left like this, the slope is negative. If you see the horizontal line, the slope is 0. If you see the vertical lines, the slope is undefined. Alright, so I'm going to use this Christmas tree. Now look at this one right here. I'm going to draw a tangent line to see if the function increasing or decreasing. Alright, so I keep drawing tangent line like this. And you see that it looks like this line right here, right? Right. So the function is increasing, right? Now, the function is increasing at an increasing rate or decreasing rate. So we start from here. We know that the horizontal line right here, the slope is 0. So we start from 0 and then it's getting steeper and steeper. So, right, so if it goes this way and if it's getting steeper, the slope is bigger. Alright, so which is the function is increasing at an increasing rate. Alright, now in order to understand if the function is concave up or concave down, okay, so we look at the streak right here. So if you see a bow like this, here the function is concave up. Alright, now let's move on to the second case right here. Alright, we have the limit of the function f of s when s approaches negative infinitive. So when s approaches negative infinitive, the function approaches positive infinitive. Look, it keeps going up forever. So it could be positive right here. So we have limit of the function f of s when s approaches negative infinitive is positive infinitive. Now, next one, limit of the function f of s when s approaches positive infinitive. Right, so when s approaches positive infinitive, which means s going further to the right, the function getting closer to the horizontal asymptote, which is 0 right here, right? So this guy must be equal to 0. Now, C. The function is increasing or decreasing at an increasing rate or decreasing rate. We just draw tangent lines, right? So we see that the tangent lines go this way, right? Which is this one right here. So the function is decreasing. Now, if we keep drawing tangent line, we see that if the tangent lines go this way, right, the steeper, the smaller slope. Alright, so this is steeper right here, and this guy getting less steep, and this guy getting less steep. Alright, so the tangent line getting less steep, and until the tangent line approaches 0, which is the horizontal line right here. Alright, so which means the function decreasing at an increasing rate, right? Because, for example, this guy equal to -5, right? This is -4, right? -3, -2, etc. until 0, right? So you see that the slope of the tangent line is increasing, right? So this is decreasing at an increasing rate. Now we need to determine if the function is concave up or concave down, right? So this is part of this guy right here, right? So the function is concave up. So D, the function is concave up. Alright, let's move on to number 3. Alright, so we have the limit of the function f of s when s approaches negative infinity. So when s approaches negative infinity, which means s going further to the left, the function getting closer and closer to 0, right? So this guy must be equal to 0. Now, limit of the function f of s when s approaches positive infinity, right? When s approaches positive infinity, the function getting down to negative infinity, right? Negative infinity right here, because it keeps going down right here, right? So it's going to be negative infinity. Now, C. The function decreasing, right? Because we draw a tangent line, we see that the tangent lines go in this way, right? Which is this one right here, right? The tangent lines go in this way, so this is decreasing. Now, decreasing at an increasing rate or decreasing rate. So we keep drawing tangent line. We see that the function starts at 0 right here. It keeps getting steeper and steeper, but steeper this way right here. So which means the slope getting more negative, right? So if it's getting more negative, which means the function decreasing at a decreasing rate. Alright. The function is concave down. If you see something like this, alright, or part of this guy, right, the function is concave down, right? So D, the function is concave down. Now, let's move on to the last one. We need to find the end behavior of this exponential function. So, limit of the function f of s when s approaches negative infinity. So when s approaches negative infinity, which means s going further to the left right here, the function getting down, right? So it's going to negative infinity right here. So it's going to be negative infinity. Now B, the limit of the function f of s when s approaches positive infinity. When s approaches positive infinity, which means s going further to the right, right? And the function getting closer to 0, right? So which is 0 right here. Now C, the function is increasing or decreasing at an increasing rate or decreasing rate. So we need to explore that one, right? So we start right here, we see that. Now we start drawing the tension line right here, right? The tension line right here. You see that the tension line is getting less steep, right? And you see that the tension line is going this way right here, right? Which means it's positive, right? It's positive, which means the function increasing. But it's getting less steep, right? Until it approaches 0, right? So the function is increasing at a decreasing rate, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.